Today we're going to start with section 1.1 and we're going to take a look at a preview of calculus. The primary point of this section is to develop an idea of what calculus does for us, the pre-calculus fails to do. Okay? There is a little bit of computational things that we're going to do as well in addition to that. So for starters, what is calculus? So in general, at the very beginning, calculus is the mathematics of change. That doesn't look very neat, but that's okay. So this whole table is actually not in your notes because it's a big giant table. It is in the ebook or in a printed copy if you have a printed copy. But it's not something I'm going to quiz you over. It's just to develop the idea of where pre-calculus falls short and what calculus allows us to do. So without calculus, we can find a specific value at a particular point, right? That's what you're seeing on the left. But with calculus, you can find the limit of that point. And I know that doesn't quite make sense, but we'll flesh that out in chapter 1. So the limit is the value that you're getting close to, even if there were, say, an open hole in the graph. The next one is probably one that does resonate. You can find the slope of a line. I feel like we spend about 3 years in high school finding slopes of lines, right? You know how to find a slope of a line, right? M equals the change in y over the change in x, rise over run, that kind of stuff. But in calculus, we can actually find the slope of a curve because, believe it or not everything is linear. Yeah? In pre-calculus, specifically we see it happen in geometry probably for the first time. You can find the secant line to a curve. So a secant line means you take 2 points on the curve and you can find the line that you create those 2 points. But with calculus, you can find the tangent line to a curve. So a tangent line just bounces off a curve, right? It just bounces against it and then comes right off. It might cross it at some other point in the future. Like it looks like you might actually see if this line's continued and this curve continued, these two crossing, right? It looks like that might happen. But it's talking about in a nearby area. Whoops, hang on. In this nearby area, it only hits 1 point instead of 2 points. Good grief. Oh my goodness. All right, so another thing you can do with pre-calculus is you can find an average rate of change, right? Your average speed. With calculus, you can find the instantaneous rate of change, right? Like right now. How is it changing right now? With pre-calculus, you can find the curvature of a circle, right? How curved the circle is. And with calculus, you can find the curvature of any curve. So let me pause for a moment here and make a general observation. What you see happening in pre-calculus, and it will continue to happen as we go down this list, is you have very rigid shapes, lines and circles. And in calculus, you get these very arbitrary shapes, just any curve, any shape, right? So you're able to do the same things, but with an arbitrary shape, whereas before it had to be a very rigid shape if you were going to do something. Okay, we're on the third one, the height of a curve. So you can find the height of a curve at any point with pre-calculus. With calculus, you can find the maximum height, right? Where does it actually give you the biggest value? With three-dimensional, everything that we've done so far is things we're going to be doing in calculus. As we move into this fourth one, it's going to be Calc 2 stuff or Calc 3 and beyond. You can find the tangent plane to a sphere in pre-calculus. In calculus, you can actually find that tangent plane to a surface, so any surface. In calculus, you can find the direction of motion along a line, right? Very rigid shape. And in calculus, you can find it along a curve. So some three-dimensional kind of things are showing up on this one. You can find the area of a rectangle without calculus. That's a pre-calculus topic. You've been doing that since elementary school. But in calculus, you can do it for any arbitrary curve down to the x-axis. So the area under a curve, and it's arbitrary. Without calculus, You can find the work done using a constant force. With calculus, you can do this with a variable force. Without calculus, you can find the center of a rectangle. There are methods to doing that. With calculus, you can actually do this for any generalized region. Without calculus, you can find the length of a line segment. Right? Imagine rulering that, if you will, right? Just measuring it with a ruler. You can do that easy. Well, you can also do a calculation with it if it's on a grid, right? Well, but you can do that with any length of an arc. That's Calc 3. So you can do that with calculus. You can find the surface area of a cylinder with pre-calculus. It's a geometry topic. May not have been one of your favorite topics in geometry, all those formulas. I don't know if you remember those, but it was something that happens in geometry. In Calc 2, we find surface areas of solids of revolution. So this is an arbitrary shape. This one looks kind of like a vase, but it's arbitrary. We can find the surface area of that arbitrary shape. You can find the mass with pre-calculus, the mass of a solid of constant density. Right? It's consistent throughout. And with calculus, you can find the mass of a solid of variable density. It changes throughout. With pre-calculus, you can find the volume of a rectangular solid. With calculus, you can find the volume of any region. With pre-calculus, you can find the sum of a finite number of terms. That usually happens in like an Algebra 2, Algebra 3, maybe pre-calc specifically type of a course where you see some of that going on and you've got some formulas to doing it. You can do this with an infinite number of terms in Calc 3. So we're going to encounter one specific example where we're going to use numerical approximation for what calculus later is going to be able to do for us so much easier. This is the tangent line problem. So the tangent line problem notices the difference between secant lines and tangent lines. So a secant line is a line between any 2 points on a shape. Now the shape can be a circle. So that's my shape on the right. That's probably the first place you've seen a secant line. So if I have this point here and this point here, this is the secant line through those points. Whereas the tangent line would be through just a specific point, say this one right here, and it would be touching and bouncing off of the curve. Right? So that's a tangent line for a circle. You can do it for a curve the same way, and that doesn't change whether it's calculus or pre-calculus. A tangent line, a secant line, we'll do that one first, takes 2 points and it puts the line through them, right? That's the secant line through that. For a tangent line, again, I'll use an arbitrary point, we'll say right here, and then you find the one that bounces off, okay? So we're going to look at trying to find tangent lines, even though that's really a calculus topic and not a pre-calculus topic. So the way that we're going to do that is by using your calculator. So go ahead and grab your calculator. Actually, I don't know if we'll have time to get to the calculator part of it today. Let me develop what's going to do, and we'll describe it. We'll do the calculator part of it, actually, because that's a little bit too involved for what we have time for. But we're going to write out a little details about what's going on between this. So in pre-calc, we can find the slope of the secant line and the way that we do this is we take 2 points on the curve and calculate the slope between them. In general, I'm going to draw the same picture on both sides. And it's going to look kind of like the one I already drew, but on a grid. So we take our 2 points and change our color. And then we draw a line between them. Right? That's the same picture we had before. That's what we do in pre-calculus. In calculus, we can find the slope of the tangent line by using secant lines where the points get closer to one another. So same picture, and we take 2 points on there. And say we want to find the tangent line right here. Let's say that's the point we want to find the tangent line to. What we do is we take 2 points on the line and we could calculate the slope between them, right? We could take this line, we could calculate the slope. And what we do is we let the 2 points get closer together. In particular, since the first point's the one that I was working with, trying to find the tangent line to, I will let the second point get closer. So I do this point and then I draw the line right here, right? And then I let the point get a little bit closer, right here, and I draw the line right here. So this is what's called a limiting process. We're letting one of the points get infinitely close to the other point, but we can continue to use pre-calculus techniques because we still have 2 points and we're still finding the slope between them. So that's the idea of what we're going to do in numerical form when we come back on Monday. If you don't have a calculator already, please make sure you bring one with you on Monday so that we can see how to use our calculator. And we'll be doing some setup with our calculator to make sure it's going to be usable for this class because we set it up just a little bit differently than you did in Trig. All right.